by Jiaming Wang, Guangyang Li, and Wentao Zhang. So for the classification problem, we did a few models. We did a few models attempts. The first one is logistic regression, and we did SVM. We did single random forest classifier, and we did multiple random classifier in a layer binary form. And finally, we also did the feature combination. So speaking of preprocessing the dataset, we found that all the 7 classes have imbalanced dataset. They have imbalanced distribution of data points, and specifically, the mood disorder has the most data. And we also found that the education and IQ columns are the 2 columns with missing values. So we fill them with means of each column. The first trial we've done is the feature engineering. So along these five features, we have combined all the 1,000 columns into these 5 big categories because we can reduce the dimensionality, and also the data will be less noisy. We have also done a layered binary search, which means we train multiple random forest model for a binary classification problem. For example, we do the classification problem for whether the patient has mood disorder or it does not have the mood disorder. And then we did that with all other classes, and then we combine all those results together, and then we do the second layer for the stratified classes. But the problem for that is we have low F1 score, and we are not able to predict, like we are able to predict does not have disease correctly, but it is very hard to predict those cases that has the disease. And here's a detail of the binary search approach. And the final approach we've done is the random forest classifier, which is the one we decided to use for our final submission. So we use MOLT to resample the imbalanced dataset, and then we train the first random forest model with all the attributes, and we get a feature importance ranking. And based on that ranking, we train a set of random forest models with different numbers of top important features, from 100 features to 1,000 features, which means that we keep either 100 most important features or 1,000 most important features. And we did a tons of that trials, and then we scored the model with the best performance. And this is the confusion matrix visualization for our best performance. And in theory, the model will perform better when the diagonal has more cases. In this case, we can see that mood disorder and addictive disorder has relatively more cases for correctly predicted cases, because these two are the majority classes over all datasets. And some potential challenges we face is that the dataset is too small and imbalanced, because the dataset is kind of like a rectangular shape, that it has so much dimensionality, but it has small size of datasets, which only contains like 800 rows. And also the imbalanced nature causes the minority classes has less data to train, and the result cannot be well generalized. And also we have the domain knowledge gap, in which we data scientists doubt if the dataset is representative of the population or not, because the data quality highly affects the performance of the model, no matter how we fine tune it. And also we don't know the dataset causes high variance. And that's all for our project presentation. Thank you.